right, guys. So today, or I guess tonight, what you guys are looking at is this is 6.5, and this is going to be the area between two curves. So I'm getting really fancy here. 6.5 area between two curves. All right. If some of you guys remember on the Unit 5 test, there was that one challenge question that was like, oh, if you have x squared and the line x, what would be that area between them? And so a lot of you guys were like drawing the picture and you're like, oh my gosh, it's this tiny little bitty sliver right here. So we're going to figure out how to do that today. Our basic theorem states that if f and g are continuous on the interval from a to b, so just kind of like what that question was. So it said from 0 to 1, and f and g are continuous. So let's just call this f and let's call my parabola g. And g sub x is less than f of x. So on that integral, all we're saying is that line G is below line F, which is true on the area of 0 to 1. And it's bounded by F and G, so that means that the area is exactly between those two curves. Then we can use the following formula to calculate that area in between. The interval from A to B, integral, my apologies, is the integral of f of x minus g of x over that specific interval. So for example, 0 to 1, 3 to 4, whatever, you could plug those in. Now, some things to note is that f of x does need to be the function on top, or it needs to be the top boundary, and then that g of x needs to be the bottom boundary. So all I mean is that if we're looking at two lines, so let's just go back to our parabola example. If I'm looking over the interval, a to b, over this interval, my line is on top, so that would be my function f of x, whereas my parabola is on bottom. Let me get a different color. So that would be my function g of x over that interval. So let's do an example. It was going to be in the do now until this was homework, so that's why that's there. It says find the area between the curves f of x equals x and g sub x equals x squared. So let's use our original formula. This is going to be the same thing as the integral. So this is from 0 to 1. So that is my interval. From this, I need to do my top line. So my top line, or my top boundary, is at y equals x. So that would be my f of x. And from that, I'm subtracting x squared. Now let's talk about the reason we're doing this really quick. All we're saying is that that area in between, if I found the area under the curve from 0 to 1 for x, it would give me this entire triangle. And then if I found the area under the curve of x squared, it would give me this guy right here. So when I subtract those two out, I get that little composite figure. So now that we've kind of gone over that, let's go back to what we're doing. So I'm going to integrate x minus x squared. And what I get when I do that is x squared over 2 minus x cubed over 3. And we're integrating from 0 to 1. And so I'm just plugging in those values. So when I do that, I get 1/2 minus 1/3. And then I'm subtracting that plug-in of 0, which is just 0 in this case. So when I get all of that done, I get that the area is 1 over 6. Let's do something else. Set up the definite integral that gives the area of the shaded region and evaluate on your calculator. All right, so this means that we don't always have to do the long math. A lot of times on the AP test, that these are in the calculator section. And you do get, there are some that you have to do by hand on your summative and on your formative, but there are several that you are allowed to use a calculator on, and it's just faster. So let's see what we're doing here. We're going from -2 to +2, so that's going to be my interval. And now I need to figure out which function is on top and which function is on bottom. So my top boundary is function g, which is 2x minus 5 plus 5. And then I'm subtracting that bottom function, which is x squared plus 2x plus 1. All right. If you were not allowed to use a calculator, then you would need to distribute the negative, combine like terms, and integrate from there. But since we can use a calculator, all you're going to do is plug that in. Make sure that you are going to math and then doing that integrate tool. So it's under math, and you can just type this in as is. And once you do that, I would press pause right now and make sure you can do that on your own. If you cannot, make sure you're Googling that. Once you do that, you should get 32 over 3. All right. I want for you to press pause right now and try to set this guy up on your own, and then we'll check over it in a second. Okay, hopefully you're good to go. So you're evaluating from 0 to 1. That top function is function f, because this is my parabola on top. So we're going to have x squared minus function g, x cubed. I would always put that in parentheses. It doesn't matter when the function is just a single term, but for example, on that previous one, if you had to do this by hand, you would have to distribute that negative to every single term, and I just don't want you to forget that. And all you're doing is plugging this in your calculator, and you get 1 over 12. If you want to say units squared, that's fine with me. Okay. Let's go over a challenge real quick. These notes are quick today. Set up the definite integral that gives the area of the shaded region and evaluate on your calculator. All right, so this one's a little bit funky because we have the functions kind of intertwined. So we're actually going to do 2 integrals for this. The first interval that we're doing is going to be from 0 to 1, because from 0 to 1, function f is on top. So that's going to be from 0 to 1, we're going to do f of x, which is x minus 1 cubed minus g of x. And then to that we're adding the second integral from 1 to 2. And this time function g is on top. So from 1 to 2, that's x minus 1 minus x minus 1 cubed. Sorry, I forgot that dx in both of those. So you're just going to do 2 separate integral evaluations on your calculator for this one right here. All right, once I get that all done, add it up, it should just give you the area of 1/2. So check, 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 make sure you're feeling good to go. All right, we are going to do 2 more examples, and then you have some practice to do for homework. And I just need to see that by Thursday. So find the area bound by f of x equals x squared and g sub x equals x plus 2. All right, now we don't have a graph. So we need to figure out where are they intersecting. It really helps to get an idea of what the graph looks like. So I know that it's going to be, I just have plain x squared, and then I have an x plus 2. So I can kind of see like where I think intersection points are going to be, but let's set them equal to each other. So there's x plus 2. We are going to do x plus 2 equals x squared. Every single time I see an x squared and I know I'm solving, I'm just going to move everything to one side and factor. And when I do that, I get intersections of -1, +2, which feels right based on my like rough sketch of what those graphs look like. And wow, that sketch is pretty rough. All right, so let's get moving on. Over that entire interval, I see that x plus 2 is going to be my function on top. So if I'm finding this area between these 2 curves, I'm going to say I'm going from -1 to +2. My top function is x plus 2, so we have x plus 2 minus that bottom function, which happens to be x squared. And I'll just give you guys a second to plug this in. Press pause if you need to plug it into your calculator. And you should get the area here is about 4.5. And remember, you can say units squared if you want. It's a good habit to get into, but it's not necessary at this time because these aren't like real world situations yet. All right, find the area between the graphs of f of x equals 2 minus x squared and g sub x equals -x on the interval of -2 to 2. So now that they're giving us the interval, I need to figure out what this looks like. So I would plug both of these in the calculator to get this graph because like I have a suspicion that this is not going to be just beautiful. Negative x squared with an upward shift of 2 is going to be going down, and then y equals negative x. So we're going to have a few different types of functions going on here. So first off, we need to figure out where these functions are intersecting. And that way I can get an idea of like how am I going to split this up and like which curve is on top where. So if you have a graphing calculator and it's allowed, you can definitely just find the intersection points that way, or you can set the functions equal to each other. 2 minus x squared equals negative x. Remember, we're always moving everything in order to factor. So 0 equals x squared minus x minus 2. My solutions are 2 and negative 1. All right. These, I see that negative 1 falls. So there's an intersection that falls between that. That means that this is going to be split up into 2 separate integrals. So from one integral, I'm going from negative 2 to negative 1. And I know on the other integral, I'm going from negative 1 all the way to positive 2. I know that I'm not going to have another one because that intersection, that second intersection point, corresponds to the end of my interval. So that only means that there's like a break one time. Now, over this first integral, or interval that we're looking at from negative 1 to negative 2, or negative 2 to negative 1, my bad, this is going to be this little thing right here. So the area between those two curves. On that, my straight line is on top, or my g sub x, my negative x. So I'm just going to say this is from negative x minus 2 minus x squared. To that, I'm going to be adding the second interval, which is from negative 1 to 2. And in that time, my parabola is on top. So I'm going to say that on this interval, 2 minus x squared is on top, and I'm subtracting negative x. And once again, feel free to plug these into your calculator since we have it, and it's just easier on time to do that. And once you get that, you should get 19 over 3. I'm going to scroll down to these practice problems. This will be on that little notes area. So I want for you guys to attempt, so I would press pause now and attempt at least one of these before, 1 or 2 of these before coming to class tomorrow. And so you have a good idea. We will go over all of these in the do now tomorrow. So all 1, 2, 3, 4, 5 of these problems we'll go over in the do now, but I would have tried to attempt 1 to 2 so that you only have like 3 to do during the do now tomorrow. All right, I will see you guys in class.